Hey guys, and welcome to Module 6. In Module 6, I decided to switch gears a little bit. Let's go on in and check it out, but first, let's go over to grades, checklist, and actually pop open the Module 6 checklist and have it as a floating thing that I'm going to put to the side for now. Okay, oopsie, I may have just messed something up. Okay, back to instructional technology. I'm viewing as a student, that's good. So now I'm going into content. And we've got 4 items in here. We've got the checklist, which you can also view. You can view it from the module, of course, and you can view it separately as this window that we got through the grades area. We've got our welcome page. We've got an issue page where I've kind of cast computer science education in Georgia as sort of an issue that I want you to think about. And then we've got our learning activities. And I put this together pretty quickly, so I hope it flows okay. It's not perfect, but it's time to release it to you guys because it's the first day of this module and I want to get it out to you guys. So do let me know if you have any problems understanding what's being asked or if links aren't working, but I've tested everything and they work right now, I think. Okay, so heading on in, so we've got our checklist page, of course. I'm going to go to the next page. We've got our welcome page, and let's go look at the course plan so you can see what I changed on here. I don't generally change this page, but when I do, I want you to take note. So I changed something, and I'm not going to go update the syllabus unless you really, really, really want me to. So if you want me to, send me an email and I can do that. But this, to me, this is an extension of the syllabus, and this is sort of the official, like, what work you're doing in the class document. Sometimes syllabi have like a table and they'll say what all your assignments are, but I don't think I do that in my syllabus, and I just say go check out the course plan for the list of assignments and what they're worth. So this formerly said Dropbox concept map, and then it said discussion module 6, but it didn't really have a title for it. And I've added the title of Computer Science Education in Georgia. The topic for this module is Computer Science Education and Technologies of Computational Thinking. So you're going to learn about computer science education in the state of Georgia and more broadly in the United States. And then we're going to play with a technology of computational thinking, and that is the program called Scratch, which you may be familiar with. If you're not familiar with it, I think you'll enjoy it. It's a little bit different maybe, but I think you'll like it. If you want to see versions of this course plan, you can go to this thing with a little clock that shows you the different versions. So if you're like, okay, I'm freaking out because she changed the course plan, what did it look like before? You can go to this October 9th version and see what it actually used to look like. It used to say concept map and discussion module 6. But now it has been changed, and anytime I make a change, I also actually write a note down here. So on 10/26, that's today, I made this change. I just felt like it was a more timely issue, and I was going and looking for research on concept mapping to to validate it as a good method. And I love concept maps. Don't get me wrong. I love concept maps. Um, one of my favorite tools is a tool called, let's just take a moment to honor concept maps before we ditch the topic. But mind mapping, concept mapping, it's a valuable tool. And XMind is one of my favorite tools. I've used this tool for 8 years and I always install it on all of my computers, and I use it constantly. It's free and it's awesome because there's sometimes you can only envision things visually. And so this concept of concept mapping is for that. So that's what the module was going to be about, but it was just not enough. There wasn't enough to it. So I thought let's hit on an important issue that's come up in the past 5 years, and it's really exploding right now, and you're probably hearing about it a lot in the news. And let's deal with that and do something fun with Scratch. Okay, so what I want you to do is read this issue page, read and view and absorb and interact with this page. There's lots of materials on here, but all of this leads up to your first activity, which will be, so you're going to read on this issue page, and then you're going to use this information that you're learning, and you're going to use it to back yourself up in engaging in discussion module 6 computer science education in Georgia, where you're going to make one initial post and 2 follow-ups to peers. Okay, so let's scroll down this really quickly. In this intro bit piece, you don't have to actually read like this STEM thing, but this is just a reference here. Um, but I do want you to read everything from item one on down. So we've got an infographic, we've got a chart, we've got a brief chapter on high-tech classrooms by David and Cuban, um, the ISTE nets for students. I think you've seen those in this class, but go check those out again because they support um, what we're talking about. Um, one second, please. Okay, sorry. It's late at night and I was just interrupted. All right, I'm back. So, I have this section is guided, so I'm sure I lost my flow, but this section is guided by these essential questions like what is the quick history of technology in schools? What are students currently expected to know and be able to do with technology? So that's why we're looking at the nets there. What are kids doing with technology today, both in and out of schools? Um, And this isn't these materials don't necessarily answer that question exactly, but the materials I've presented here show you what is possible. And this article is really key. Kafai and Burke is a fantastic article on computer programming and what it looks like now in schools. And it's this more um, we're seeing a lot of applications like Scratch and Alice. Um, we're seeing a lot of more coding in communities. We're seeing more remixing, kind of like what you see on YouTube, or you see it in various online communities. Like back in the 80s when we were learning computer programming, you just couldn't really share your data. But now you can remix. So you can remix on the Scratch website. Scratch is the tool we're going to be playing with in your when you actually build something for this module. So you can share and remix other people's Scratch artifacts, just like computer scientists do. Like they use a tool called GitHub when you work in computer science or you do software development, and they can share and remix their code that way and make stuff together. So it's kind of a shift that we're seeing in instructional technology in this piece of instructional technology related to computer science. So read this article. It's really user friendly and short and to the point. It's based on a longer research article by these guys. So read that really nice, easy to read article. Watch this TED Talk with Mitch Resnick from MIT. He's talking about why kids should be learning how to code. See if you agree with his arguments. Um, Optionally, you can watch ISTE's short video on computational thinking. Finally, what is the state of computer science education in Georgia? Kind of talk to you about some of the issues we see in Georgia, and then you can read page 17 of this report. It'll show you how Georgia is actually a little bit ahead of other states in the United States, amazingly, on this topic of computer science. And it's thanks in large part to a lot of people in Georgia that have worked hard on this. But still, we have more distance to go in order to make computer science education accessible to kids in Georgia. Um, a quick question about is it bad that industry like Google and Yahoo want our kids to code? Because if you'll notice, they really want to see people coding. So think about that for a second. That's just something to consider. And finally, should we teach computer science in elementary school? And I actually, so that's a question there, sort of a stimulating question that this person in this article addresses. So those are your these are your stimuli leading up to engaging in that discussion. And I actually want you to keep that discussion fairly brief. I think I said I want you to limit it to maybe, did I say 350 words? Let me check. I wanted you to keep it fairly limited. Um, 350 words, which can be a lot, but don't just say, don't, I want you to be specific and on point in this discussion. I know it's really easy to use a bunch of highfalutin words and expressions and not say anything. So I want you to be succinct and show me that you actually engaged in those materials and you are saying something beyond computer science education is great and here's why it's great. I want you to like kind of get to the nitty gritty fast. So that's why there's this range of 150 to 350. I think 150 is actually pretty lengthy, isn't it? I just didn't want it to be too long because um, I do ask a lot of questions here, but you can be succinct. Okay. Let me go back to here. So we've got this issues page. So let me pull this checklist back over here. So you're going to read the issue page, what the thing we just looked at. It's got a lot of stuff on it, and it's going to take several hours if you actually do it. And then Module 6 activities. You're going to engage in the Module 6 Computer Science and Education in Georgia discussion, making one initial post and two follow-ups. Then we're going to shift gears and you're actually going to get to make something. You're going to learn a little bit of computer science programming in the program Scratch. You're going to complete Scratch tutorials. You're going to set up a Scratch login. You're going to use my instructions Scratch artifact to create your very own superhero in Scratch. You're going to submit that to the Dropbox. You're going to give me a link to your artifact. You're going to publish your artifact in Scratch. You're going to give me that link in the Dropbox. You're going to share that artifact with classmates at Peer Feedback Module 6 Scratch Artifact. You're going to make one initial post where you share it and then two follow-ups to peers. And then I want you to respond in a Google survey that I created as well, where you just kind of tell me about your previous experience with Scratch and what you think about it. So that's what you're going to do. So let's go to the next page, the actual session activities page. So you read the issue, you read all this stuff on the issue page, um, but you have the Module 6 activities page that's loading very slowly right now. Oops, and then I clicked out of it on accident. Okay, so we've got our issue, Computer Science Education in Georgia, Scratch Artifact, the Superhero Challenge, all your information there, links to various tutorials with time estimates for how long it should take you. I want you to watch these videos on doing all these things with sprites. And it's programming. There's programming in there. They'll teach you programming throughout that. Then check out the Scratch Superhero Studio, so where other people have made superheroes in Scratch. And then I want you to read these instructions. This is just scratch paper, so if you were to print these instructions, you could draw your superhero here. You could think about these aspects of your superhero. Is he evil? Does he have a special power? What is, or what's his name? What evil does your superhero fight? What problem does he or she solve? And then here are step-by-step instructions that I give you to do a very simple little scratch thing, and you can do extra extensions if you want. Here's the Google survey that I want you to respond to. Let's see if it works. Yes, it works. And then your checklist is on the last page. And then with points, these numbers represent the points tied to the 40-point Scratch project. So that is it. That's what we're doing. It's about computational thinking, computer science education, hot topic in instructional technology, and it's something that teachers and people at schools are going to be expected more and more to do with your students across the curriculum. All right. Thanks so much.